Good morning, all y'all. Greetings. How goes it? I hope your days are better than mine. Michael, I was just looking at your email. There have been issues, as you guys know, with homework 4 grading. These last 2 days have broken me. Good morning, Benny. Good morning, Sophia. Good morning, Schwartzmeyer. It's good to see you guys. Good morning, Ryan. Ryan, I've gotten a lot of your emails. That's fine. Don't feel bad about over emails. It just means I have more to go through. Just means it might take me a while to respond. Yeah, I know, Sophia. Yeah. Like I said, these last 2 days have slightly broken me when it comes to the grading of homework 4. I have been increasingly frustrated, and I don't have time. Like, I've got like 20 emails in my email inbox right now that I just haven't been able to sort through and respond to everybody. I'm hoping, I'm gonna contact all of the TAs and graders and just get it fixed by anybody as soon as possible. So hopefully it's fixed by tomorrow. Yeah. That's not on you guys though. Unfortunately, you guys are probably also frustrated with seeing that. The number of emails tells me that there's been an issue that needs to be fixed, and it seems to be systemic. So I am trying to get it fixed as soon as possible. Yeah. And it's mostly just Section H. Section G is mostly okay. It's just Section H. Sorry. Which it's you guys. So I will fix that. I will get it fixed. Anytime it needs to be outsourced, it just means it's going to take more time to finish. Outsourced meaning I can't do it. I don't have time. Anyway, how are you guys doing? Happy Wednesday. We are partially through. We're in week 6. So the programming project, thank you, space engineering student. Good morning, JR. The programming project is going to be posted later today. It's also on my list of things to do. It's been slightly delayed because I'm dealing with this issue with the homework. You will be able to work with up to one other person. So I will get all that information to you. I didn't want to tell you that you guys could choose a partner until you had all of the information. So I want you guys to know the entire scope of the project, even if you don't know all of the content yet. So you will have that information tonight. You will be able to choose a partner. Starting tonight, there will be a UB Learn survey. Yes, so the other instructors have a different mechanism that they're using for people to select their partners. I'm doing it through UB Learn's, a UB Learn survey. So I didn't want to show it to you until you had all of the information. Because some people might be like, oh, that seems doable. I can work alone. Some people might be like, oh my gosh, that's so much work. Like, I definitely need to find someone. So you'll have all of that information. So your partner has to be with the same instructor. So for you guys, if you see my wonderful face every Monday and Wednesday, then you should choose a partner that also sees my wonderful face every Monday and Wednesday. So it just needs to have the same instructor. So for you guys, there's less people in G and H, but I mean, that's still 120 some people. So you should be able to find somebody. You can also use the Discord. I am not going to coordinate partners. If you do not know someone, go to the Discord, post there. I'm going to leave it up to you to find a partner if you do not know someone. So that's why you've seen people already posting who their instructor is and if they would like a partner. You do not need a partner. That is completely up to you. You have until the midterm to choose one. But once again, you will have all that information today, and you'll see it show up in your list of things to do each week. I've just been waiting to tell you guys until you have all of the information. AP Cruzy. No. The auto grading script does not check. You should practice using DISP. So starting out with fprintf is fine. Change it to use DISP for practice. But the auto grading script does not check for that. It's a nice, fun tidbit of information. Okay, it is 11:30. Let's go ahead and start learning some new things. So on Monday we went over our relational operators. We went over our logical operators, equality operators. All of those are the techniques we learned for arrays. We also went over logical indexing. So there's a lot of material over there that corresponds to arrays. This week, or today, not this week, today I am going to go over if statements and switch statements. So we're starting to get a little more complicated in our programming design, and we're doing something called branching. So now we get to choose between doing one thing over another thing. So we're going to have a bunch of code, and we get to say, if this happens, do this. If this other thing happens, do this. If this other thing happens, do this. So we're starting to see some more complicated code design where we get to choose whether or not we want to do one section of code over another section. So let's go ahead and go through some examples. Once again, I'm going to demonstrate this through examples. So here's my first example. It says prompt the user to input the following variables from the command window using the specified prompt. So we see the word prompt. We know I need to use the input function. So you already see that written down here in MATLAB. So area equals input. Here's my prompts. Enter in an area. That's a number. So I just stop there. In units and out units, input, enter in the input units, out units, input, enter in the output units. Note, input units and output units, I'm expecting text to be used there. So I have my additional option, that's my S in quotes. Okay, and it doesn't matter whether or not you use double quotes or single quotes for this, both of them will work just fine. So you see, I have the single quotes, here's the double quotes. Okay, so I've done that. Woohoo, check. Okay, now we get to some options. It says if the user enters in an invalid value, so if, keyword, if the user enters in an invalid value, print out an error message. So print out an error message where XXX indicates the invalid value entered. In the notes for this week, here we go. I have a statement here that says if statements should be designed or written to minimize logic tests and remove redundancies. So there's 3 steps I have written out that can kind of help us guide how to write if statements. And I know we haven't written them yet, but I just want to put us in the right frame of mind for writing our code. So first, we want to determine how many mutually exclusive paths are needed. How many options do I have? How many questions am I asking in order to figure out which code I want to execute, which action I want to determine? If required, order from most restrictive to least restrictive. This typically happens when we're looking at numerical ranges. So I'm not going to go over any of those examples today, but this doesn't always need to occur. Sometimes we might need to order them, but generally we're starting out with how many mutually exclusive paths are needed. Once we know that, we can go ahead and write our selection statement or our branching statement or our if statement. There are 2 different kinds of if statements, if statement and there are 2 different kinds of branching statements, an if statement and a switch statement. I'm going to go over both today, starting with if statements. You can always use if statements. That's usable in any situation. A switch statement is just an if statement that we can use for specific situations. And like I said, I will go over that. Okay, so here, if the user enters in an invalid value, print out the given error message. So I have 2 paths. They either, 1, enter in a valid value, or 2, they enter in an invalid value. So I have 2 options. It's either correct input or an incorrect input, valid or invalid. If it's invalid, I'm going to display a message. Okay, so for area, I have on my chart here my valid options. So for an area, a valid option is a positive numerical value. So when the user enters in an area, I'm going to check if it is valid, if it's positive. You can't generally have a negative area. You can, looking at integration, areas below the x-axis are negative technically, but we are going to talk about, like, in this instance, like a practical area in terms of like real life. Like, you don't have negative areas in real life. Real life being like physical, like an object you're calculating the area of. Okay, so I'm gonna assume that is valid. So okay, so let me write my if statement. I either know it's gonna be valid if it's positive or invalid if it's negative. So anytime you write an if statement, you start with the word if. It's really nice, nifty. If. And then next to that goes what's called our conditional statement, where here I'm gonna check to see if something occurs. So in this instance, I'm checking to see if it's a valid entry, if area is greater than 0. I'm going to assume 0 is an invalid area. Once again, practically, you cannot have a 0 area for something that exists. Okay, so if area is greater than 0, that's my first option. Then I go to my second option. My second option goes next to an else if area is less than or equal to 0. I have my 2 options, greater than 0, less than or equal to 0. And then every if statement ends with an end. Okay. If my area is greater than 0, so if I have my invalid option, I'm gonna do nothing. And I'm gonna print out do nothing. Just because. If my area is less than or equal to 0, I'm going to print out my message. Okay, so someone mentioned using disp, AP just mentioned using disp over fprintf. I'm going to review how to use disp. So here's my message that I'm printing out. The input area where I enter in something is invalid. So I'm combining text with variable data and variables. So I need my open close brackets. Whoop, those aren't brackets. My first set of text looks like this, the input area. And then my variable is area. That's a number, so I need num to string. And then my second set of text is invalid. Okay, there we go. Here's my first if statement. If the area is greater than 0, do nothing. Otherwise, the area less than or equal to 0. Else if the area is less than or equal to 0. This is one way that we can write this if statement. If you have 2 options, typically what we do is we have an if else. So I would say if area greater than 0, do nothing, display, do nothing. Note, if my area isn't greater than 0, it's going to be less than or equal to 0. So I could just say else. So here's another option. It's either do this or do this. I really only have 2 options here. If area is greater than 0, if area is less than or equal to 0. Those are 2 completely exclusive options. So I could use if, check for one of those options, and then have an else to check to get any of the other options. Okay, since they are equal opposite, or since they're opposite, since they are 2 different ranges that are completely separate, and there's no other options, like it's either greater than 0 or not, I can use an else. So an else is kind of like my, good question, Flora. So an else is like, it's a catch-all. So if this isn't true, at least do this, and we'll see more examples of that. So can we do 3 if statements without the else statement? Yes, so I'm getting there. I think what you mean 3 ifs as in 1 for each. Okay, this is another way we can write this if statement. The third way that I'm going to demonstrate writing this if statement is, note in this one, I'm doing nothing. Typically, if we're doing nothing, we don't really want to include that in an if statement because it's unnecessary. So I could think of it as check to see if it's invalid or leave it alone. So I could say if area is less than or equal to 0, then display my message, and then just be done. So in this instance, it doesn't even check to see if it's valid. It only checks to see if it's invalid, and it does something if it is, and then it's done. Okay, so here are 3 if statements that technically do the same thing, but it's just they're different. They look different, but they all do the same thing. So we're starting to get to this point in our programming where we're getting more complicated. And we're gonna see different design preferences. One of these is more typically used than others. So this one is more typically used because it's the least number of comparisons. It's the smallest version that does what we want it to do. And as you get more advanced and more exposure in your programming, you will be more comfortable with writing an if statement that's much less complex than something that where you check all the options. Okay, so let me demonstrate how these if statements work. Let me put in a breakpoint, run my code. Okay, so I'm gonna enter in an area. Let's enter in -24. It's an invalid area. Okay, so I entered in a -24. Area equals -24. I hit this if statement. What happens when we hit an if statement is it's going to check to see if this first question is true. Is the area greater than 0? In this instance, it's false. So what it's going to do is it's going to jump over that and go to check the next condition. If the area is less than or equal to 0. So this one's true. When it hits a true one, it's going to execute the code inside. So notice this is indented. It's going to execute the code inside of that if block. So it displays the input area -24 is invalid. When you have an if statement, it chooses one of the sections of code to execute. One, or if you don't have an else, 0. So it skipped over this one because this was false, and it executed this one because it was true. If this was false, it would have executed 0 as well. But whichever one is true first, it's going to execute the code inside. Okay, so let's look at this if statement. It's going to do the same thing. It's going to check to see if this is true, if area is equal to 0. That's false. And else, though, it's going to always execute the else if it gets there. So if all of the other conditions above are false, it's going to at least do this. So it's our default case. At least, at minimum, do this. So it displays the message and then it exits. For this one, it checks to see if this is true. If it is, it executes the code inside. If it's not, it skips over it. So if area is less than or equal to 0, that's true. It prints out the message and then it's done. Let's do it again if my area was +24. So if the area is greater than 0, that's true. It executes the code inside and then it's done. It doesn't even check this anymore. It's just, I've already found a true one. I'm done. Let's get out of here. Same thing here. If the area is greater than 0, it's true. It does nothing and then it exits. If the area is less than or equal to 0, this is false now. So it's just going to completely skip over everything inside. The difference between this one and this one is in the first one I have an else if. Else ifs and ifs are always followed by conditionals. They're always followed by some sort of comparison. An else, however, is not. There's no conditional here. It's just else. At minimum, do this. Default. If nothing else is true, do this. Okay. So here I have 3 if statements that do the same thing. Like I said, you will become more comfortable with writing if statements as you get more practice. Okay, so let's go on to the next part. So now I want to check to see if my input units are correct. And here are my valid values: square kilometer, square miles, and acre. So same idea, I'm going to use an if statement. Now I have 4 options. Either it's equal to square kilometers, it's equal to square miles, it's equal to acres, or it's none of those. So start with your if statement. So if it's equal to square kilometers. Okay, input units is a string. When you are comparing strings for equality, you want to use the strcmp function. strcmp is short for string compare. So that's what it's short for. And it's used to compare strings or character vectors. It's used to compare single quote strings. Double quote strings can be compared using our normal relational and equality operators. But single quote strings, the ones that are read in by input, need to be compared using string compare. So I'm going to compare my in units with square kilometers. So now I'm checking to see if in units is equal to square kilometers. That's my first option. My second option, else if string compare in units is equal to square miles. Third option, else if string compare is equal to in units to acre. Fourth option, anything else. Else. Okay, I don't have a specific else if fourth option. I have an else fourth option that just says if it's not any of these, it's everything else is invalid. So it's just an else. So same thing, same idea here. If it's equal to square kilometers, do nothing. If it's equal to square miles, do nothing. If it's equal to acres, do nothing. If it's equal to anything else, I'm going to print out my message. The input units, now I'm printing out in units, is not recognized. Okay, so here's one way I can write this if statement. If it's equal to square kilometers, do nothing. If it's equal to square miles, do nothing. If it's equal to acres, do nothing. I can also think about this in a different way, where instead of there being 4 options, I can have 2 options. 4 options, 2 options. Either it's valid or it's invalid. Yes, so MTM, yep. So else if is pretty much saying, so you can read this as if it's equal to this, else if, otherwise if it's equal to this, otherwise if it's equal to this, otherwise here's the default case. So I can think of it as there's a valid option or an invalid option. So I can say if it's equal to string compare in units SQKM, if it's equal to square kilometers, and now I can start to use my relational or my logical operators. I can use and or to start combining these questions. So if it's equal to square kilometers, or if it's equal to to square miles, or if it's equal to acres. And I'm going to continue this on a new line so we can see everything. So now I'm combining it into if it's valid. It's valid if it's equal to square kilometers, or square miles, or square acres. So I'm taking all of these 3 and combining it into one by using my and or. So it helps to really talk out loud what you're trying to do, because if statements follow the language that we speak. Okay? So if in units is equal to square kilometers or square miles or acres, it's valid. So Nick, no, that's a good question. An else if cannot be substituted with an else. So in this instance, kind of true, because if it's not greater than 0, then it's going to be less than 0. So in this example, it's either one or the other. This else if is kind of redundant. I don't need it. An else is always the last thing. So it's always going to be if, else if, however many else ifs you want, and then an else. Okay, so here I'm saying if it's valid. It's valid if it's equal to square kilometers or miles or acres. Square acres or miles. Square miles or acres. So if that's true, do nothing. Otherwise, here's my else. Print out my message. So here I've broken it down into even less. I have an if to check if it's valid and an else if it's not valid. Once again, though, we have this do nothing option. In general, we don't want if statements, if blocks to do nothing. So I'm going to design this code. I'm going to rewrite it where it's going to be negative. So I'm only checking to see if it's invalid. So if this is valid, it's invalid if it's not equal to square kilometers and it's not equal to square miles and it's not equal to acres. So I'm just going to I'm going to invert this statement. So an inverse of or is and. So I'm going to replace all of my ors with ands. And then an inverse, if this is true, is if it's not true. So I'm putting in my nots. So here I'm checking to see if it's valid. Here I check to see if it's not valid. So if it's not equal to square kilometers and not equal to square miles and not equal to acres, then it's incorrect. It's not recognized. So you'll notice we're starting to get a little more complicated with our conditionals. So we're going to use all of those. Things that we learned about on Monday. Use our less than, equal to, and, or, all of that fun stuff. And we're going to combine all of those to start to ask our questions. And it takes practice. Once again, speak it out loud. Try something. If it doesn't work, try something else. I'm not going to lie. I spend a lot of time trying to figure out why my code doesn't work because I wrote the wrong conditional. So it's just making sure that you're recognizing. So JTM, so string compare is checking to see if input units is equal to square kilometers. So I can't say in units equals square kilometers. It's not. No, I did not. It's not gonna work. This doesn't work. It would work if they were double quote strings, but they're not because in units is a single quote string. So what we do is we replace this with string compare. It's comparing the two strings. It's checking to see if they are equal. Once again, this is where we have a difference between double quote strings and single quote strings. Okay. So here's another example of where we have three if statements that do the same thing. One of them might make more sense. You will get more familiar with writing the shortest if statement as you practice. But all three of these do the same thing. This one is preferred because it's the least number of comparisons and it's the shortest if statement. In general, we try to not have code blocks that do nothing. But it's valid. Okay. Sometimes I start this way and then I'm like, wait, there's a better way to do this. And then I redesign it after I've already written and figured out what I'm trying to do. Okay. But make sure you're speaking things out loud, talking through it, using language to help describe what you're trying to do, and that can help identify what we actually want to do. Okay, so last one, I want to check if my output units is correct. So my output units, same thing. I have three options: square kilometers, square miles, and acres. So I am going to just copy and paste this if statement and just compare for my output units. So now it works for output units. So it's checking to see if my output units is not equal to square kilometers and not equal to square miles and not equal to acres, then it's invalid. I print out my message. If it is valid though, I don't need to print out my message. I can just skip over that code. Okay. Okay, there's our first set of if statements. Hopefully that helps illustrate how to write them, illustrate how they work. Let's keep going. More examples. Okay, so given my inputs, given an input area, given a input units and an output units, I want to go ahead and convert the input value, my input area, from the input units to the output units. So once again, how many options do we have? I have square kilometers. If my input is square kilometers, then I can either convert it to square miles or acres. If my input is square miles, I can convert it to square kilometers or acres. And then if my input is acres, I can convert it to square miles or square kilometers. So in theory, it looks like I have these options. It looks like I have these specific paths. So let's go ahead and start. Let's start programming this up. If string compare my in units is equal to square kilometers. Else if string compare my in units is equal to square miles. Else if string compare in units is equal to acre. End. Okay, I don't have an else here, and that's fine. You don't need an else. You can have an else. It's a good practice to have an else, but once again, it just depends on your application. I don't have an else here because I'm assuming that based on my input, good question, A. Lombard. Based on my input, it's going to be one of these three options because I've already checked if it's not. So string compare and string compare I. String compare I is for string compare case insensitive. So if there's an I here, then it doesn't matter if it's uppercase or lowercase. It will treat it all as all lowercase or all uppercase. So here it's case insensitive. I like to use string compare I a lot, just as a double check. String compare is case sensitive, which means it needs to be exactly this. It will not match if it's a capital SQAKN. Okay, string compare, it doesn't care. Okay, so if my input units is square kilometers, then here's my options. I can either go to square miles or acres. So once again, I have options inside of here. So I'm going to write another if statement. So if string compare, now my out units is equal to square miles, else if, I'll write it all together, else if string compare out units is equal to acre. And same idea in here. So if my input units is square miles, then I have two options. My output units could be square kilometers or acres. And same thing in here. If my input units is acre, I could have square miles or square kilometers. I'm not showing the conversions in here because I'm focusing on the design of the if statement. So what we have here is what's called a nested structure. So you can think about each code block inside of an if as its own separate program. So if this is the case, do this. Do this little piece of code, this little separate program. That little separate program, that case block, that code block, can contain any valid MATLAB code. Any valid MATLAB code means it could contain another if statement. You need to follow the logic. So if string compare in units equals square kilometers, then I need to make another decision. If my output units is square miles or my output units is acres. So any valid code can go inside of here. Think about it as its own separate little program. If string compare equals, or if input units equals square kilometers, do this section of code. If it's something different, do this different section of code. If it's something else, do this other section of code. That section of code can be any valid MATLAB code, including another if statement. So this is where we have what's called nested structures, specifically nested if structures. But it's just preference. You just follow the logic. You need to talk things through. So if you think about what you learned about in ES 199, for those of you who weren't transfer students, first thing first, identify the problem. When you talk about the problem out loud, when you try to understand what the problem is, it's going to give you a better indicator of what your solution, what your code is going to look like. So make sure you're understanding the problem. Make sure you're writing out, what are my options? What does this look like? How am I going to design my code? And sometimes in the homework documents, we give you hints about how to design things, how you should write things. But like, you don't have homework hints in the real world. You don't have homework hints moving forward. So you're practicing. The more you practice, the better you're going to get at identifying what your if statements should look like. Sorry. Well, we usually have to program the actual conversion in another function. It depends on how you're asked to design your code. You might be asked to write a function that does this unit conversion, but then you would be told to write a function, but not necessarily. Okay, so this is one way we can design our code in order to do our unit conversion. I'm going to show you another way. So another way we can design our code is to use some sort of intermediate unit conversion. So here's our unit conversions. I need the one for square kilometers, square miles, and acre. So I don't need all of them. I have more than I need. But notice they're all in terms of square kilometers. So another way I could design this code is I could say, if my string compare in units is it equal to square kilometers, else if string compare in units equal to square miles, else if string compare in units equals to acres. And what I can do is I can convert all of these to square kilometers. Convert to square kilometers, which is redundant, but just for completion's sake. So I could convert everything to square kilometers and then have a separate if statement that converts from square kilometers to my output units. So here's another way to also do this code. Rather than do each thing separately, I could just break it up into two if statements, convert my input units to square kilometers, and then convert my square kilometers to my output units. So once again, we're starting to get to more complicated code design, where both of these are valid. One is a little bit more user-proof than another, depending on how you write it. But it's differences in your background, in how much programming experience you've had. And if you're new to programming, starting out here is completely fine. The key piece is identifying what are your different paths. Those different paths are going to indicate what your if statement should look like. Okay. Those are if statements. Let's talk about switch statements. So, a switch statement. There we go. A switch statement. So I already mentioned that you can always use if statements. Every time you write branching statements, every time you are trying to decide to do one piece of code over another piece of code, you can use an if. That is always the case. In certain situations, you might be able to use a switch statement instead. And in general, if it produces more readable code, a switch statement should be used. A switch statement can be used when we are testing a variable for equality in each of our conditionals. Yeah. So if you look at this if statement I have written here, I'm checking to see if out units is equal to square kilometers, if out units is equal to square miles, if out units is equal to acres. So every time I'm checking to see if out units is equal to something. This is an indication that I can use a switch statement. To create a switch statement, we start with the keyword switch, spelled correctly. Switch. Yay! And then what we're going to do is we are going to identify that variable that we're going to compare for equality every time. So I'm comparing out units to square kilometers, to square miles, to acres. So my variable is going to be out units. And every switch has an end. In between there, we are going to identify our cases. What are we comparing it to? So I type the word case, and then I'm going to insert what I'm comparing it to. So I'm comparing it to square kilometers, square miles, and acres. So those are my options. Case, square kilometers, case, square miles, case, acre. And then in switch, we don't have an else, we have an otherwise. Testing. Sorry, once again, my handwriting. Writing on a tablet is so much different than writing on paper. The tip of the stylus is so, like, smooth. I don't know, it just feels so much different than writing on paper. There's a lot less friction to slow you down. So testing, that's still not even well written. Testing. There we go, that's a little better. So we're testing a variable for equality. So here I'm testing to see if output units, or if out units, it's equal to square kilometers, if it's equal to miles, if it's equal to acre. And then same thing goes in here. Fun fact, if you want to properly indent your code in MATLAB, you just highlight all of it, and then you can press Control I. You can also press the indent here. It's just really nice. Okay, so there we go. So a switch statement is exactly the same as an if statement. So let me go ahead and comment out a bunch of this stuff just for kicks and giggles so we can look at how these work. Here we go. So I'm gonna put in my debugging breakpoint. As you guys are writing your code, it might be useful to you for you to start using these debugging. So if you ever want to test your code to see what is happening, you can put what's called a breakpoint. So you can place it at anywhere there's a line of code. And when you run your program, it's going to stop there. And then you can execute it one line at a time. You can see what your variables are at. You can see, you can highlight some code and execute individual pieces to see what's happening. But it might help to start debugging using the debugger. It's really nice in MATLAB. So I'm going to run my code. I'm going to enter in a value, an area 45. My input units, I'll go with square. I'm going to go with acre. My output units, I'll do square mile. Okay, so now I'm here. I have stopped here. So I'm gonna enter this if statement. So first it's gonna say if out units is equal to square kilometers. So I step, that's false. Output units is not equal to square kilometers, so then I go to this one. If string compare out units is equal to square miles, that's true. So it would execute any code in here. There's no code in there, so it's just gonna exit. So for the if statement, it checks to see if this is true. If it's not, check this one. If it's not, check this one, and keep going until you find something true, or you hit your else. In this instance, it will, it would also potentially find that none of it's true. Okay. Same thing for a switch. These two operate exactly the same. It's not always the case in other languages, but these two operate exactly the same. Okay, so switch, I'm going to compare out units to square kilometers. If that's true, I'm going to execute the code inside. If it's not true, I'm going to go to the next one. So that was false, so now I'm checking to see if it's equal to square miles. That's true, so it would execute the code inside and then exit. Okay. Let's do another one. 45 in units is acre, square kilometers. And then acre. So it first checks to see if that's true. That's false. So it checks this one, also false. Checks this one. This one is true. That didn't do anything because there's no code in there, but then it jumped to the end. Same thing for switch. First it checks to see is output units equal to square kilometers? If it's equal to square miles? If it's equal to acres? If none of those were true, it would hit my otherwise. Acre is true, so it skips to the end. Okay, so like I said, a switch statement is only used when we are testing a variable for equality. Why is that blue 95 in the command window? Because that states it stopped at line 95. So the 95 indicates this line here. That's where it stopped. So it's just identified, hey, I'm here. Tell me what to do. Yeah, that's why it's there. It's not an error. It just indicates this is the line number that it stopped at. Okay, so a switch statement can only be used in certain situations. It can only be used when we are testing a variable for equality. So that means we can only use it when we are working with text, like we saw here, or string or characters, like individual characters is fine, or if we're working with integers. So these are the instances where we can use a switch statement. So for example, So if I asked the user to enter in an integer, then I could use a switch statement. I could compare this integer to check what it is. So case 1, case 2, case 3, case 4, case 5, etc. Otherwise, then end. Okay, so now it's checking to see, is A equal to 1? So it's checking A equal 1. Checking A equal 2. Checking if A is equal to 3. Checking if A is equal to 4, and if A is equal to 5. Note, checking for equality is a double equal sign. So if A equals 1, else if A equals A equal 2, else if A equals 3, etc. If you leave off that double equal sign, MATLAB has gotten much smarter, and it will give you an error. It will tell you, this is invalid. This is invalid MATLAB syntax. Remember, the single equal sign is assignment. It's saying store a value of 3 in the variable named A. So when you're checking for equality, you need a double equal sign. In the past, MATLAB did not give you an error. It gave you potentially a warning, but it still technically worked. It just would be wrong. I don't know what you're asking, JR. What are columns in our code? What does that mean? Okay. We cannot test equality for floating point numbers. So while you're answering that, I will move on. So we can only test for equality with integers and text because we're looking for exact values. When it comes to floating point numbers, or non-whole numbers, we can't test for equality. Oh, that's a good question. So here's an error. It says line 13, column. So let me run this. So line 13, column 10. It means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means there's an error at 10 spaces in, or 10 characters in. Yeah, that's a good question. So column 10 means 10 characters in. Okay, so for floating point numbers, remember there is some sort of accuracy and precision issues with floating point numbers. And you read about this in like week 1 or week 2. I can't remember which one it was. But computers cannot store infinite precision. They need to cut it off somewhere because they're finite pieces of machinery. So it might be really far down the road. It might be at like the 10th digit past the decimal place. It might be at the 15th digit past the decimal place. It depends on how much space you have to store your numbers. But there's going to be some cutoff point. There's going to be some indication of where a floating point number might be practically equal to another floating point number, but it won't be exactly the same, because when you check for equality, it's checking to see if every single number is correct, all of the numbers. For integers, it's not an issue because you have zeros infinitely one way. For floating point numbers, though, you don't have zeros infinitely one way. You have some sort of rounding that occurs. It might be really far down the road, but somewhere it occurs. So when we compare floating point numbers for equality, we are going to use this sort of expression. We're going to say ABS, num1 minus num2, greater than a certain threshold. So if it's greater than a threshold, that means they're not equal. If it's less than a threshold, they are equal. And this is what I do for your homeworks. Yes. So AP, if you're using switch, I believe it's always case sensitive. You can Google that. If MATLAB has an insensitive switch, I don't think it does though. I've never tried. But you have functions called lower and upper that you can use in order to convert what you're comparing all to lowercase or all to uppercase before you do your switch if you need to. So there are ways to get around that. Okay, back to floating point numbers. So if, for example, for your homework, you're, depending on what operations you use, so you might use nth root, and I might use raised to a fractional power. Or I might use nth root and you use raised to a fractional power. So there are some differences where we might get the same answer mathematically, but somewhere there's some rounding that makes the fact that my answer might be slightly different from your answer. So what I do is I say if ABS num1 minus num2 is greater than 1e to the negative 10. So if my answer, so my solution answer, is compared to your student answer. And you can alter this threshold. I think for your homework, I use 10e to the negative 5, I think is what I do. But when we are testing for equality with floating point numbers, we can't just say solution equals student. We have to say that if we subtract the two numbers, is that difference practically 0? Okay, so keep that in mind when you're trying to do your operations. A lot of times we don't necessarily check for equality for floating point numbers. There are applications for it, like I just mentioned, for your grading script to see if you got the right answer in MATLAB Grader. But a lot of times we're just looking at ranges for floating point numbers. Okay, I believe that's all I wanted to mention for today, which is great because we're out of time. Are there any, you guys have had great questions, keep them up. I'm very excited to see your questions, very, very thoughtful. Is there any final thing to mention before we head out? So I do have one more example that I'm gonna put in a video. It's a little more complicated. It's basic if statements, if, else if, nested statements. It's used to calculate the roots of a cubic function. So I will post a video of that. Yeah, so Nick, your question, there's nothing different between a switch and an if. It's just the syntax. Sometimes a switch can be used to create clearer code. So sometimes it's easier to read a switch statement versus an if statement. My music is still going. Can you not hear it? So sometimes you use a switch statement because it's easier to read. But for the purposes of MATLAB, if and switch behave exactly the same. What is the ORS behind your head? Yeah, it got slow. The music got slow. It's randomly shuffling through a whole bunch of different music, so it just got slow. I don't know what an ORS is. Do you always have to write otherwise? So for a switch, just like with an else or with an if, you don't need an else. It's good practice to have an else. It's good practice to have an otherwise, but they are not necessary. Yeah, but they are not necessary. But once again, it just depends on your application. It depends on what you're trying to do. So the better you understand the problem, the better you're going to be able to design your code to account for all of the different situations, all the different cases. Oh, so okay. So that's from the header. So here is the header, the operators. I just haven't moved it. Yeah. Okay, any final questions on this material? I like this material. It's good. So what we've been doing the past couple weeks has been a little bit more specific to MATLAB, which all programming languages have arrays to some extent. In MATLAB, it's a little bit different. But all programs have if statements. So here, this week and next week, are very applicable material that apply to other languages. So every language is going to have their version of an if statement. So we're really getting into specifically programming logic and how to design our code with all of these structures. Okay, I will do my best to email and resolve all the homework issues. And I'll see you guys next week.